My sir visible, right?
Yes,
Just
they
wanted
are.
to make sure. Yeah. Okay.
Yes, sir, they are. Am I audible?
Yes, you are.
Okay, so we can
Yes.
start. Good evening, everyone. I'm Mitali Madhushmita on behalf of Steellun, the official material advantage chapter of and expertise in the field. Our speaker has made significant contributions to the advancement of artificial intelligence and data science. Please join me in welcoming Mr.
Because I see that you guys are probably quite exhausted after the regular class and everything, but I'll try to make it as interesting as possible. But this is a little bit of a difficult subject, so I would request everyone to pay attention so that we can really as a team we can progress and make use of this 1 hour effectively, right? Okay, so having said that, let us get into the stuff, right? Sorry, I have gone to the presenter mode. Is it visible well now? The screen?
Yes, sir, it's visible.
Okay.
Yes, sir, it's visible.
Okay. So before I start, regular disclaimer is all the material that I am now going to talk about in this next 1 hour is based on my experience and all that, not necessarily represents any organizations or my organization's point of view. So what we are going to discuss today, there are quite a few stuff I think that we will discuss, but we'll touch upon quite a few things there, right? Means and probably it will give you a breadth of knowledge on machine learning so that you can pick and choose into your area of interest, because there are various area where you can actually really go deep into it and do your own study and etc. And definitely, if you need any help on where to look for the resources and etc., please reach out to me later on. I can help you also. So we are going to talk about what is machine learning, and then definitely a little bit on the evolution of it. Then means I have put in the prerequisites. Those who are probably kind of starting it very new, they should kind of do some of the prereq stuff basically to understand it's better if you are trying to take it seriously at a later point of time. We'll discuss about some of the machine learning types, learning methods. I will introduce you to the deep learning, because that is probably the most talked about thing right now. And then we will talk about how do you really transitions to this deep learning from a traditional learning, what things are changing, what are the different types of deep learning even. I will just touch upon the transfer learning, because that is something changing the game, right? Now we must have already heard about ChatGPT. You guys probably are using it for your assignments or whatever. But this is built on a concept of this transfer learning and the foundation models, which I will give you some intro to it. And means if you really want to use this foundation model, ChatGPT is on one of the foundation models from OpenAI, but there are other foundation models available in various places. If you really want to use or try some of the foundation models on your own, what are the kind of things that you should keep in mind, right? Because that is something it's very relevant for today, right? So what is machine learning? Machine learning is the art of study of the algorithms that you learn from examples, right? It is like the way we learn, right? So we from our childhood, what we see certain evidences, certain phenomena, and based on this phenomena we see certain output, right? So, and that is the kind of learning that we used to get. That's how we also learn. Machine also learns that way, most often that not. And that is there are definitely some other way basically it also learn, or we can make it learn. But largely speaking, it is learning from the data or experience that it has got. Now, why is it important to you? Means it's not my area, but I have done a little bit of a digging into this matter, and what I have found, in material science also, this is quite relevant right now, because the way traditionally, I think the new materials are were actually discovered more in a manual manner and etc. That is no more the fact, because that is like, takes a lot of time to find out the characteristics and or even to find out a new material, right? There is a use of lot of in simulations nowadays, and that's the area of like material informatics, right? And if you are interested in material informatics, I think there are quite a bit of work that is going on right now as I speak. And in fact, there are certain foundation models also probably coming up, which are like ChatGPT from OpenAI, which you can use potentially and like, give your own data and then try to find some output. You will see a general version of it so that you can like, relate it to your own field, right? So hence it is very important if you are really interested in the material informatics, right? So how is that, what is the evaluation of this machine learning has happened, right? And like, in fact, like, it has, if I see a set of this basically, like which is part of what, you will see a timeline as well in a horizontal, as well as you'll see a kind of a set diagram, right? Means overall, like artificial intelligence is the study where actually we are talking about the making machines more smarter, right? Means it can really respond the way humans do, right? So that has got an artificial intelligence baked into it. It will have a cognitive functions within the machines, right? Now, one subset of that, how do you really make it happen, is through the machine learning that I have touched upon a few minutes back. A specialized part of machine learning is deep learning, a type of machine learning, and foundational models are like ChatGPT are part of the deep learning, a specialized deep learning. So we will actually see all of that in this 1 hour. And if you see that we are talking about artificial intelligence from 1960s, right? So that point of time, and right now we are in 2020s, and there are several times basically these things have evolved. Deep learning, so to say, which is based on artificial neural network, is not something that has come in 2010s, right? In that area, like it came in much before, like 90s, but it actually needed lot of resources like computing power and etc. That was not as commoditized as it is today, and hence like it really got I would say it has got a traction in this time, right? And right now, as you can see, like we are talking about foundation model, which are even bigger, right? And it is computationally more heavier, but we have that power, we have that hardware available, and etc. Right? So that is how this thing has evolved, right? Now, what are the kind of prerequisites that you need? There are 5 disciplines that I think you should study a little bit, because that is kind of very foundational stuff that it will give you, so that you can understand that matter in depth, right? Means not for this session, of course, like in this session, you will need a very basic stuff of, let's say, linear algebra or calculus. I'm sure you all are aware of. But if you're really trying to do a little bit of a deep dive on machine learning, then probably you have to go back and do this study, right? So field of statistics, probability part of statistics, but like as an individual discipline that I have kept, statistics I have kept more on the hypothesis testings and the measure of like central tendency, etc. Right? So given a set of data, how the data is distributed, what is the mean, median, standard deviations of the data, how do you really find out the outliers in that data, right? So that kind of distributions, that is it really normally distributed, and how is the nature of it, and so on and so forth. That area I'm more talking about. And definitely the other area like regression, classification, there are different statistical techniques that are there, which kind of gives you a foundation of whatever we are going to talk about later. Probability is, of course, like there is nothing deterministic in this. The machine thinks that. Is there a question somewhere?
Sir, sorry to interrupt. I think your slides are not changing.
Oh, is it?
I think you have shared the presentation instead of the screen. Yeah. Now it is changing. I mean, it was there on slide 1 for all this.
Okay. Oh, sorry. So I have been talking about. Okay. So you have not seen the content. that what we are going to talk about?
No, sir.
But
No.
I have actually voiced over. I think it's okay, right? Means
Yeah,
you
yes.
have understood why it is
Yes, sir.
you
Yes,
know
absolutely.
useful.
Please continue.
And yeah, this is the timeline that I was talking about. Yeah, thanks for letting me know. I will keep in this mode actually. I think there's some problem if I go to the foundation in the presentation mode. Okay. So I was talking about present, like, the statistics and probability, like any machine learning algorithm that you write, it is not really deterministic saying that it is 1 or 0, right? It is somewhat between, right? It's a probability of this, something happening this, or chance of having this getting this value, right? This is the way probably, if you even ask like whether if you train a machine to detect the shapes, right? If you have given squares, triangles, rectangles and the circles, etc., etc. It might say that yes, this is I think this is a triangle with certain probability, right? So it is always a probabilistic score that it comes up with, and that's why we definitely need to understand, like, how that probability is calculated or computed, right? There are different like Bayesian techniques of probability, calculations. There are other techniques of probability calculations or likelihood calculations. Now that probably you need to study a little bit. Some of the things that are more important I have highlighted in blue there that you can also pay more attention to it. Linear algebra, yes, absolutely important, like super important for you to really study machine learning, because anything and everything that you do, there has to be a main mathematical representation of this thing, right? So for example, let's say if you are trying to let's say you are there in a healthcare center to go and treat every individual, you treat a herd of people, let's say. That's the phenomenon, that's the critical situation you are in. How do you do the here you are doing a kind of a classification or a clustering. I'll come to that. I'm using the terms early, but we know about this cluster and etc. But ultimately, it's a physically, from an English term of cluster, you can understand that having fever is yes or no, right? 0 or 1. So your attributes becomes that way. It could be like a continuous field, also like a temperature. Means what is the temperature that he is having? It's a continuous variable, but there are discrete variables like 0 and 1, or let's say it would not always be 0 and 1. It could be few discrete variables as well. So you need to really model this thing into a mathematical representation. Now, every person has come in, he is represented by a set of numbers based on certain variables, right? How do you really represent that? What is our way of representing a set of numbers? Is vectors, right? So, and how do I really find out this person is similar to this? By finding out, if I can imagine an n-dimensional vector space, that I can find out, yes, this person is actually sitting in a vector space in certain point and is related or nearby to the other person, because that person is having a similar or nearby position in that vector space, right? So that is why linear, and when you are going for a computation, everything is actually, I mean, when you actually sum it up for a lot of people, then it becomes a matrix representation, right? So all computation that you will do through linear algebra. There is no divisions or multiplications of every variable that we'll do. You will do rather matrix operations to really get it done quickly. So all your libraries that you will use when you will go to the programming, the last part, there also they will use the matrix operation. So representing through the linear algebra terms in the vector space and matrix operations are very important, right? So you need to be very good at that to really code in linear algebra. Sorry, code in machine learning. Now you have got to know like what is the need of the programming. Any language, Python is nowadays is very good, but any language for that matter you can use. Calculus is, again, what you are trying to do is an optimization problem, right? So typically what you will have is a hypothesis. So for example, let's say if you get if you're trying to predict price of a stock, at that point of time, you will have certain attributes, right? Whether there is a corporate actions, like any dividend has been issued, or there is a reason for heavy buying on that stock, etc. Is there anything that has happened that can natural calamity or natural phenomenon which is counterproductive for that stock or for that company, or what is the financial result of that company? There could be various things that is actually directly or indirectly affecting the stock price. So those are your variable. And what you are trying to do is try to regress that, right? So when you are trying to find out, and you have got certain data points of certain days, so you are detecting a pattern. How would you detect a pattern? That pattern is not always a single line. It could be a curve. It could be a hyperplane. It could be like if it is a three dimension that you are dealing with, it is a plane. If it is a higher dimension, n dimensional system, it is a hyperplane that it could the ultimately your patterns are, right? So you're trying to detect a pattern. And then when you are having a new variable, new set of variables, and for that day, and you are trying to detect it, you are getting that price, right? But how do you really get that hyperplane? It is by assuming a hypothesis, like, yes, this is the, like, you start with one hyperplane, and let's think about like two variables. You start with one line, right? And then trying to minimize the, when you are having this line and with your training data, you have an error. And I will talk about regression and we will let it, you get to know more. But essentially, you are trying to find out the best fit curve, if I can use that term. And that time you are trying to minimize the error because you started with certain line, which is not right, right? And you actually move that line to the best fit line. What are you essentially doing? You are minimizing that error. Minimizing means differentiating your variables. Differentiation of that variables is very critical to minimize that error. So that's the area of calculus that you are, means, because all these loss functions that we will talk about, that is where you will definitely need this. And there would be, we will actually talk about multi-layered optimizations in when you go to deep learning and etc. And we'll see that the application of chain rule, etc., that will be coming. And how do you really minimize? There has to be a mechanism, right? There has to be an optimizer. So that is where, like, in statistics, you learn gradient descent. So that gradient descent is needed. So these are the few things that I just touched upon, but these are the 5 disciplines you need to pay attention. Now, let's start with the types of the machine learning, different types of machine learning. So regression is the most simplest part of, like, easy to understand. I was talking about stock price. How do you regress that point, right? So for example, there are few data points are there. You are trying to find out a pattern, trying to predict something, right? So that is how pretty much is the regression. Now, it is not always is a prediction of the stock price, but it could be the data points are same data points getting in every day. Like, for example, let's say the weather, right? Weather forecasting, or something which actually changes over time. Like, so this is like it could be the forecasting as well. In healthcare, I have talked about like the predict patient's outcome based on the factors, right, such an age and etc. Again, you are trying to find out these variables and find out a pattern. What in the mathematical term you are getting, like just a few minutes back that I was talking about that. Let's say there is a set of trained data which are X and Xi and Yi's are there. I's are like, it can go to 1 to 100 if you are having 100 sample to train on, right? Now, you are trying to this, and this X is a vector, right? Because it has got many fields, X1 to Xn, right? So this is a representation of a line that you have got in an n dimension, where, sorry, this will become a hyperplane, but in 2 dimension, it will become a line. But that's a function that you have assumed, right? What you are trying to minimize is what is the value of the function and the real value. So Yi's are the real value. So the squared error of this is summed over it, and that's what you are trying to minimize, right? So sum of the squared error. It Y squared error because there will be sometimes negative, so you need to really make it in a positive, right? So that's how the minimization function you will do. What is the optimizer you will use? I talked about gradient descent and stochastic gradient descent. it needs more study on the stochastic gradient descent, what it is, and etc. When you are talking about like different cycles in which you do this optimization, each cycle you are adjusting your gradient descent parameter. So then it becomes a stochastic gradient descent. But as such, the gradient descent you have to do to really do the minimization. So this is how the regression works. Similarly, how the classification works, the second type of machine learning, right? Now, the classification is you are trying to figure out which class it will belong to. You are not really predicting a value of the stock. You are predicting which class it will belong to. So for example, the mails are coming, you are trying to predict whether it is spam or not. How do you really, means if you are trying to manually trying to do, you look at the subject, you look at the sender, you are looking at some of the terms or phrases that are getting used, etc., etc., right? So those are the attributes that becomes your, again, attribute to learn from, and you do a classification, whether it's a spam or not, 0 or 1. Again, you can actually think of this is a line or a plane or a hyperplane that it will separate this data, right? So for example, if you're talking about let's say support vector machine is one of the classification algorithm, and those who would study further on machine learning, this is like very interesting and very powerful algorithm that is trying to widen, like it is trying to find out such a plane which will have the biggest separator between these two classes, right? As if like you are actually sitting the symptoms, like patients with a certain set of symptoms in one class and symptoms with other class, and etc., etc. That means your separators are very, like, you are having in one corner of them, you are making them sit in another corner of the room, you are making the third group in another corner. So you are trying to really separate them with a good classifier, so that when the doctor comes in, he will not really find it difficult, right? So that is the kind of a separator that you are trying to. So your separators are based on the symptoms that the patients had actually talked about, right? So that's how the classification things works, right? And if you are using a similar way, you are using the regression techniques. After that, you can use a function which is like I have shown it with sigma, which is nothing but a sigmoid functions, which the value comes in between 0 and 1, right? So, and like with the probability of it, it will either go to 1 or we can make it 0, right? So if it is close to 1, then we'll say it 1. If it is close to 0, we can make it 0, right? But it will not exactly be 1 to 0, right? So the out of these functions, whatever that comes in. Now think about it. What is the definitely your in this case your error of root mean square will not really work. So what kind of a error function that, or a cost function that will be? So I leave it to you basically for some further study. Definitely I can give you an answer later on, but yes, I'll let you think a little bit. Now, third one is the clustering. Clustering is, you may think like it is a similar to the classification, but it is not really, because the clusters you don't like the classifications you don't know when you are doing the cluster, right? You are having some idea that these are similar and you are doing the clustering, but you are not really having the classification. These are having a COVID positive symptoms, and these are not having COVID negative symptoms. Even we are having, you may actually cluster them with like 5 clusters, but you need 2 classes, right? So at the time of clustering, you are trying to see some homogeneity in the data sets, and based on that, you are doing a clustering thing. So that is also very useful to, let's say when someone is sending, you are getting a mail or a campaign. Let's say, okay, if you buy this, you will get an off, right? Maybe your parents are getting it by the purchase pattern and etc. You might also be nowadays, you might be also getting, because you guys are also doing certain purchase and all. How do they do that? Do they really do sometime like targeting just you? Often than not, it will not be so. There are personalized campaign also in the market, but they do segmentation. Now you belong to a segment or a cluster where actually they are sending this campaign, right? Now that is where, like, this clustering is very, like, plays very an important role, right? So, and like market basket analysis is again another cluster, like what you buy together, right? If you buy bread, then it makes sense that you will buy, or it is, there is a tendency that you will buy butter as well, or egg as well, right? Something like that. So the market basket analysis actually influence what are the things are kept in the same aisle. When you go to a superstore, you find some of the things are nearby, right? Those are actually like thought through, which people are buying together. That is what is called market basket analysis. They are clustered together, right? So that's how this thing will work. Now, there again, like, there are different algorithms. I just named one, which is k-means algorithm. There are k cluster. If you think you are trying to minimize the distance between this centroid of the cluster and to the with the elements within that cluster. How do you do that? You start with, again, the way you started with one arbitrary line. You start with arbitrary points. Let's say you think in a two-dimensional manner. You try it with arbitrary points in like two centroid. Let's say you think there will be two clusters. You will slowly think that yes, there are, and you are assigning the elements or the data points to the cluster which it is nearer to the centroid. Now, if they are separated correctly, then in the second run, when you are trying to do you find a new centroid after assigning the centroids to these points, then you will find a new centroid of the cluster, and you do the same thing. You will find that it is not at a certain point of time. We'll find that things are not changing. It is actually remaining in the same cluster. The data points which was there in cluster 1, those are there remaining in the cluster 1. That means you have reached to that steady state. So this is exactly mathematically represented here, is that you are trying to find out the minimum distance between these k clusters on a set of x, like x as the variables, where the centroid of the clusters are mu. The distance between the x and mu's are like sum of the distance are minimum, right? That is how you are trying to minimize, right? Now, what would be the distance function? There, I have written distance square, like the distance is the square of the distance that is coming in. What would be the distance function? The answer is, like, you can definitely use Euclidean distance. You have all studied Euclidean distance and etc. But that may not be useful when you're talking about vector space, right? So think about it. What could be because there are two I wanted to talk about is about generative. So, and this is like what you are experiencing right now with ChatGPT, right? So you are writing something, it is generating certain things. No, none of the other cases, 3 cases that I have talked about, it is generating anything. It is, of course, like predicting one value, 2 values, or etc. But it is not really having a generation capability, right? You have written 3 words, and it is not really writing it is trying to write the 4th word, 5th word, 6th word again, and to try to complete the whole sentence, right? That is what happens in the ChatGPT, right? And this is a special kind of machine learning types where this text generation, even code generation, image generations, like, you say that, yes, this is generate an image of mine as if that it was drawn by Van Gogh, right? That kind of things are available, and you will get to see that in the social media too often than not. But these are, and we will talk about how these things will happen on the algorithm side very briefly. But this is something generative algorithm that kind of comes in. That depends on a transformer architecture where it is trained on, and the training algorithm we will use, it is self-supervised training. Humanly, it is not possible to teach them about the whole Wikipedia, right? Somebody must be doing it automatically, right? That's why it is called self-supervised learning. We'll come to that in a moment. And it will learn through that self-supervised learning in a state where now you give it a new problem that it has not seen before, but it can generate, right? So there are techniques of this transformation learning, transfer learning that it uses, and it uses this foundation model. So foundation models are like Llama is a foundation model which comes from Meta, like the Facebook company, right? Or Flan is a foundation model. It comes from Google. There's a foundation model which comes from Amazon. There's a foundation model which comes from Microsoft. There's a foundation model which comes from Google. There's a foundation model which comes from unrelated data also, which it has not seen, it can respond to. And I will show you in the next slide how it is doing that. In a traditional machine learning, let's say this is an image which I want to classify. What would I have done? I would have actually done the hand-coded feature extraction, that these are the features, because hand-coded means hand engineered, means like I'll do the statistical analysis. I'll do, for example, chi-square, or find out which one is highly related. I will find out the the mean, median, modes of certain elements of it. I will find out several other things, some features of this image, and then run a classifier. So this is a feature vector H that I will run a classifier, which is, let's say, G, and with certain weights, and then I will have some Y predicted. What deep learning does is, this kind of classifier is a multi-layer stuff, and I have shown only 3. There could be many. So I start with X. I don't have to do the feature engineering. I don't have to think about this hard-coded, the manual labor of finding out which feature will be good or bad, and etc. I start with X only with certain W. I minimize this, and then I get H. I get H, then start with V, another set of weights, and then I get Z. I get another. These are the layers, the hidden layers I'm talking about, right? And then I get Y. What is happening, what we have seen by doing so, is that at every time there is a representation of the input data. And mind this word, please pay attention. There is a, as and when we go there, to the right, there are some representations, some low-level representations is there, and gradually there are high-level representations of that data points, which can be used at a later point of time. But right now, just pay attention to that. There is some representations of that data. That means there is some mathematical stuff there which represents through which I can say that this is an aeroplane. But can I really, what is the kind of representation it has got? Representations are like, does it have wheels? Does it have this kind of edge? Does it have, let's say 2 wings, etc., etc., right? So that if I really be able to train this with lot of images and all, I am already having certain representation. Representations can be developed because the weights are already trained and I have the weights. I can use that model. I don't have to do any training. Now that with that representations, I can add my own stuff with some little more training on that, and then I can get that result. So that is what I will go to when I will talk about transfer learning. But just hold on to that thought of that representation. The other type of deep learnings are the convolutional neural network, and very interesting stuff here, right? And this is for image. Now you see that, let's say an image is a pixel by pixel, right? There is an image can be divided by depending upon the resolution of that image. It is actually a matrix. If you really see any photo in a 2 lines of Python code and then try to see that in a matrix form, you will see that it has got, if it is, let's say 28 by 28 kind of a resolution, then you'll find a matrix of 28 by 28. And if it is a monochrome, you'll find that it is between 0 and 254, right? That is the value that it has got. If it has got RGB, then it will have there are matrix is a 3-dimensional matrix, the one matrix, and then there is a depth of R, G, and B. There are 3 values for blue and green and red. But think about a monochrome, let's say. Now every row has, every cell of that matrix has got 0 to 255. Let's say these are the values that you have got in this step 1. What is the kind of what is called convolve? Convolve means you are actually taking a small piece of thing, let's say a 2 by 2 thing, and you're passing it over. And when you are passing it over, you are creating a weighted sum. So these are it is called this kernel. If you see, this is a kernel, 0, 1, -1, 2 is the kernel that you have used. What I have done is 1 into 0 plus 0 into 1 plus -1 into -1 plus 0 into 2, right? That is what it has given 1. Okay. So and now that becomes a new value. That means I am trying to convolve over this. I'm sliding it across from top to top left corner to the right bottom corner, I will do the sliding, and I will have a smaller thing, right? And then if I really get a negative number, which I may get, so I will use ReLU, where the negative numbers will become 0. Otherwise, the positive number will remains the same. Right? So there is a rectified linear unit that I can use function where it will become that way. Then I use some pooling operation that where if it, let's say this is the new matrix that I have got, let's say 4 by 4 that it has become, and then I will do I will shorten it. I'll do, maybe I can do an average pooling, I can do a max pooling, I can do a global average pooling, right? If I do a average pooling or max pooling, this is the kind of matrix it will get generated. Or if I do a global average, that 4 by 4 matrix becomes 1, right? So that means I'm just shortening it, but I am keeping some characteristics of the image, because the image, like pixel by pixel, it doesn't change so much. I am keeping the characteristics of that image by shortening it, because I don't have to really compute that much, the whole image. I'm trying to detect certain features, right? Now, how does it really do that? Now, this is the kind of a convolution operations. So if I use 7 kernels, let's say the 7 kernels that I am using is one for detecting, let's say, curved edge, a circular thing, there's a vertical portion is there or not, or this is a kind of an edge is there or not, and I'm trying to detect 9. I'm having 7 kernels, which will create this 7 shortened image by pulling again 7 shortened image. These are the representations of 9, or any, for that matter, any number, and I can have a fully connected layer. After that, this is a normal deep learning network to find out the outputs. And this very much, this capability of, like, the representation of it in a different phases of the same thing, which we are really repeating. Let's say you see this called conval ReLU and then max pool con ReLU. So you will keep on repeating this to have certain representations. And then you actually have this normal deep learning, like fully connected layer that we are calling out in the right hand side, and do a softmax is nothing but the, like, in making it between 0 and 1. So you get, so that you get a probability kind of a score, that's what it is, right? So this is the idea that I wanted to leave you with for CNN. And so far what I have been talking about is the foundation for the transfer learning that can be done. So we have started at 7:10. Are you guys okay to continue till 8:10?
Yes, sir.
Okay. So transfer learning is nothing but that, yes, there is a representations at every layer that I have got. If I really chop it off at certain case, and I just get the vectors or vectorial representations of this, or the weights basically that are already learned, can I use these weights to determine my new data, so that I don't have to really go through this huge amount of big network and train it again. I will work with a very small network and do with a limited set of data that I have, but still get a fascinating results. That is what is the, in fact, that is the foundation of this foundation model, or the ChatGPT that we are talking about, right? If when you are giving the ChatGPT certain prompt and getting some results, there is some examples that you are giving. Either it's in a form of prompts, like, okay, give me this like this, for example. Let's say you can write, okay, write me and help me writing an appointment letter like this, and then let's say there is a appointment letter format that you have given. With that is the training data that it has got, it will generate that thing, right? So that means it is using the weights that it has already learned from the big training that it has already got, right? Now, with this concept, there are also some interesting things have happened, especially the image in the text world. Text, so far that we have been thinking a word as a one-hot vector. So for example, if I think about, let's say there are 50,000 words, let's say in a English dictionary, right? That means if I try to represent the word, let's say go, that might be 256th position of the 50,000 vocabulary. So that means if I really have to have a represent go as a vector, it will be a vector of length 50,000 with everything becoming 0 and 1 at the point of 256th position, or something else like another word which is there, that is called one hot encoding of that vector, right? That is the mathematical representation of that word. But when we are now having this deep learning network, what if I try to predict, let's say I have a sequence of word and I'm trying to predict this sequence of word or one word, let's say at a certain position. If I really chop off the right hand side layer and take the last hidden layer, there will be a vector or a set of weights. Is it not representing that word? That intuition is a very, very interesting intuition. And I want to leave you with that intuition, right? And you don't have to really understand it fully, but intuition, if you really get, that is the most important thing. And you can probably apply it in your material science domain as well. The representations, the last representation is that will be reduced next. So you want represent right? You want to predict words, sequence of words, and go very high. Right? This is how the in the sequence there's variables were disjoint. So x1 where there's relationship between that because they are independently. If you see that I have a patient who like set of patients which I am dealing with, he was having cough if he's having a fever. Then no point of yes having cough or having a fever as a two attributes. You can have one attribute, right? Related attributes don't keep only the independent attributes which are unrelated, like they're quite independent. But when you are talking about text or like voice and etc., there is a relationship because what I have told in or written in past that has got a lot of importance what I will write in subsequent sentences. In the generative algorithm, this becomes immensely important. And this kind of architecture then we use, which is called sequence to sequence model, and it is called RNA because the same stuff is recurrent way we are doing. That's why it is called recurrent neural network. Now, think about what would be your, just now I have talked about that, like you have got probably the answer, like how would the representation of the text would be, or a word would be, and how the memory will be, like, will that be computationally challenging? Yes, it will be computationally challenging to keep this memory for long. Instead of 3, if we have a lot more, then it will become issues, right? So there are techniques also that actually we have got this challenge got over this challenge. That is the, after all the things, something like the foundation model, and I transformed it from, because it has got that representation already built in, and it is now, this can be like path breaking paper, right? So you can search for that, and it's, I think, openly available. This is the whole RNN that I have talked about. They have really good paper by Google. They put it, really study that. But the whatever foundational knowledge that we have discussed so far about representation of the things, that is what is they are trying to use, right? Through encoding and through, again, decoding and all that, right? So what we see, instead of having every model, every deployment, every training, there is a way you are like, it has really got traction with the coming of ChatGPT, right? In the textual world. But you need to really be very careful while using this foundation model, because this is like you don't know where the data means. Often test that in your Excel suggesting. It's very important to also think that how much that has been used. That could be, the training data could be, biased, right? It could be what we call like there could be an ethnicity angle to it, right? So it is not, it might not be socially correct, right? It might be biased on certain certain kind of people. It might be biased on certain philosophy, so forth. I actually do these ethical checks, and what is the data that you are not, that we should check, and definitely, like, do a cost benefit analysis. You don't, from a commercial purpose, stuff like classification, but would you use it? Means, do you want to really go from one stop to the other where you can use a cycle? Do you really rent a bus? You don't, right? So that's kind of an analogy. So if you really have a if you really have a very high, like, lot of things, heavy stuff to be done, definitely use those kind of models. But for small purpose, though it is, like, working very well, this may not be, like, cost effective to use them. So with that, I now open it for questions. We can go for a few questions.
Sir, related to the issue that you said, that keeping the memory may be very difficult for several cycles. So, can we use the compression methods that are already being used?
No, it is not the memory that we are talking about, the RAM or that, right? So it is not that memory. I'm talking about, it is having the knowledge of what has happened last. So for example, if you have a long sentence and you want to have and everything, let's say step is T means you are right now, the step is T, and then you want to go back to T minus 10. Let's say 10th word before, right? So minus 10 position that you want to go to. So the more you want to go to the left, more accurate will be your results. That is true. But that means you have to really keep that into the memory, what has happened. Why I am saying it is difficult is that when you are trying to do the optimization, you will have a vanishing gradient problem. So there are ways we have overcome it through another architecture called LSTM. So what I have shown you is the plain simple neural network, recurrent neural network, but there are little bit of a tweak and variation of that as LSTM. It's called, I think, long short-term memory that has overcome it. That's a different kind of an architecture, but that's more complex for you to study. But you first should study the how that RNN really works. But this is not the memory of your machine memory.
Yes, thank you, sir.
Yes, Vishal Kumar. You have a
Good
question.
evening, sir. Sir, can you please
Yeah.
tell me how we can use this machine learning and deep learning in metallurgy? Because I am from the metallurgy field.
Yes. So, see, I think I'm not. My field of work is not on material science. I actually work mostly on the financial domain and etc. But for you guys, actually, I did a little bit of a study and etc. What I could figure out is that the simulation that I was talking about, you need to really make this simulation faster. What you are trying to do, you are trying to predict some property. Maybe it could be a microscopic property or it could be a macroscopic property of certain material based on certain conditions. Now, principally, all materials will fundamental physical theorems that we have. Right? Now, that not given to you means what would be your, let's say, conductivity of certain material if the temperature reaches other things. You don't have to really simulate it or physically do that, but you can really do that extrapolations or that kind of a pattern detections and predictions to get to that field. Like a regression problem means, are you really saying that yes, what is the stock you're predicting a stock, right? Stock price and all that. So, or a future, let's say whether it will rain or not, right? Similar problem in the material science. Now, it could be a attribute predictions or it could be the reverse. Materials finding, this is the most important from nowadays, because nobody actually goes now, or very less people will go in a traditional way of really making this material in the lab, because that is time consuming and all. So, but I think you should definitely check it with your professors and all, like what are the different new fields. Material informatics is the field where I think there will be a lot of applications of this machine learning.
Thank you, sir.
Any other question?
Sir, Devnath Gupta has it.
Yeah.
Yes, good evening, sir.
Good evening.
Sir, how can we means learn machine learning to identify a burning problem in market and means provide a solution to it? Means if a beginner wants to learn it, what are the step-by-step process he can approach to machine learning? Not particularly related to material sciences, but anything in general, means anything which the industry requires.
Yeah, so machine learning definitely needs a lot of industry. Variance of a machine learning only comes from the data of that industry. But it is such kind of thing is that you definitely need to have a very good foundational knowledge of it. All the things that I have touched upon today, if you really do it, go in depth of each of that, right? Means those are like a chapter of a book itself, right? And I can give you a good book name. The author is Ian Goodfellow. Ian Goodfellow's machine learning books or deep learning book is is worldwide used. Very well written, very well accepted books, and that's a fantastic book actually. So that is a book that you can study. Once you have the foundational knowledge created, Then you apply that with your own domain type of data, like the domain that you are interested in. If you are
Okay,
interested
okay,
in banking and financial, you apply it with the banking and financial. If you are
okay.
interested in something else, you do that way, right? But
Sir,
that
basically what machine learning does means deep learning is something that it is similar to neural networks, as you said, like the neurons. But what is exactly machine learning? Means
now
how the
machine learning is deep learning is a part of machine learning. You remember that
okay,
what I was talking about is a special type of machine learning. But
okay,
there are other, like you don't have to use deep learning always, right? You can use simple regression techniques of, for example, logistic regression I talk about, which is for classification. I talked about decision tree. It's a very widely used thing for doing the classification. Like, so for example, let's say there are lot of variables and you are trying to take a decision, right? Based
okay.
on that, whether I will buy this stock or not buy this stock. Now that's a decision tree. Means it is, yeah. So there are different algorithms that you need to study. Means of course I cannot cover all the algorithms now, but these are the different techniques or algorithms that you study to identify. First of all, I think this should give you the idea whether it's a regression problem or a classification problem. What kind of problem? Should I apply a cluster first? Then I should do something with, I will go with skill that you need to adopt, right? And once you identify that, then there are a lot of algorithms already there. You need to use this smartly, like how to use it. And for
Means
example,
first I
let's say
feel
if you're not
first
using deep, hmm?
means sir first I have to master machine learning basics from textbook, YouTube videos, and then the selected domain I am interested in, I have to apply and meet the industry what the industry requires.
Right. That's that. Unless and until you want to use a foundation model and just use some prompts and do that, right? There would be some operational stuff, like, but that is like very. I would say it's on the not the at the creation of machine learning. It's on the usage of the machine learning there, right? Using of a foundation model and how to really tune it is on the usage side. There will be a lot of usage in the industry with through the prompts and etc. that I talked about. But those guys are not really building a machine learning model. The ones who are training it or fine tuning it, they are having a new machine learning model, right? You remember that chart that I talked about, which is like this one, right? You create some new models. For that, you can use that route. But as I given you that analogy, you don't always rent a bus for that, right? For going from one place to the another. You may very well be actually, go with a cycle, but in a very good cycle, right? So that is what
Okay, okay, thank you, sir.
Devnath Gupta, I think you have
Yes,
raised.
so
Sir, there's a
Yeah.
question in the chat box. I'm reading it out. It is, are the simulation in software like ANSYS related to machine learning, and how the development in machine learning models can help us improving them?
Okay. So means, are you asking that the machine learning machine learned model can write code? Yes, it can nowadays. It can, and that gives you a productivity, but it will never be able to give you the algorithm or a pseudocode. So you have a business problem, let's say, right? You want to do solve a business problem. You have some steps. If you, those who understand or have written computer programs, I am sure a large percentage of people have done so, that they have you understand the pseudocodes or the logic, right? Once you have the logic, then machine can write it in Java, in C, in Python, whatever, R, but it will not be able to figure out that, because the logic is something like, very, very difficult. Right now, I don't think we are there yet. We could be, but we are not there yet. Once you have that logic, then it can be, so at least it will have some error, but it will give you some fair amount of a code base also, which you can then change. I don't know whether I have answered your question, whether actually I understood the question correctly or not, but if it is not, then please ask.
Yes, sir. I'm understanding that one.
Mhm.
Sir, I'm asking that like machine learning models are used to generate predictions. So simulations softwares also we use to generate the predictions about how the material will behave.
Mhm.
So are these related?
Yeah, they are related. That's why I said that there is a lot of usage of this machine learning coming up uh, in this area of that
Yes.
material informatics.
Yes, sir. Thank you, sir.
Okay. Is there any? If there is no more questions, then possibly we can end it here.
You may write your queries in the chat. No more queries.
Thank
So
you
we will
for
conclude
guys
today's
for.
event now. Hope you all enjoyed the talk and gained an useful perspective regarding the field of machine learning. On behalf of Steellun, I extend a heartfelt gratitude to everyone present here for being a part of this event. Thank you, Mr. Dey, for giving us your valuable time and insights. And a special thanks to all the participants who made this event a success. Thank you,
Thank
everyone, and
you.
good night.
Nice talking you. Thank you.